The bridges are structures designed to connect two points, separated by natural obstacles mostly. The design of a bridge depends on the use, scale, among other important features that define the structural conception. Exist three major types of bridges, and basically the structure bases the design. And in parallel, the structure is chosen according to the span of the bridge. A span is the distance between the bridge supports, whether they are columns, towers, or the wall of a canyon. The span depends on the type of bridge. The explanation about why the different types of bridge allow more or less span is based on the behavior of the forces on the different types of structures. Types of bridges. Beam bridges is basically a rigid horizontal structure that is resting on piers. The weight is traveling directly downward and is supported by the piers. It is considered a good option for short spans, and if the distance is long, the beam can be supported for more piers. Can be expensive for long distance because the materials. The concrete is a good option, but this must be reinforced by steel, because the bridge must resist the compression and tension forces. And not in all places the piers can be built. Arch bridges. It's a semicircular structure with abutments on each end. The design of the arch naturally diverts the weight from the bridge deck to the abutments, and they are always under compression. The force of compression is pushed along the curve of the arch toward the abutments. Practically, there is no tension because the natural curve of the arch and its ability to dissipate the force greatly reduce the tension on the underside of the arch. It is good for short spans, and for the construction we can use several materials, like bricks, stone, steel, concrete, among other materials. The disadvantage is that it needed a lot of material for the construction even the span is short. Suspension bridge. It's one where cables or ropes or chains are strung across the obstacle and the deck is suspended from these cables. These types of bridges can cover long spans, but they are very flexible, so don't resist a lot of weight. For example, they can be used to build railways. Benefits. The invention of the bridge means a progress in many aspects of the society. In economic terms, the cost of travel and the financial benefits increase the social cohesion and sharing resources rises. Today, bridges allow easy travel across major rivers and estuaries, over the new obstacles of motorways and railway lines, and between neighboring islands. International trade and travel depends on shipping and air routes, but efficient distribution networks depend on bridges. The Golden Gate Bridge. The Golden Gate is a suspension bridge that connects the city of San Francisco to Marin County, located in the United States. Was designed by Joseph Strauss, Irving Morrow, and Charles Ellis, and the construction finished in 1937. Was opened in May 27. Before the construction, the only short route between San Francisco and Marin County was by boat across a section of the bay, and in 1820, a ferry route was built to transport water in the beginning, and then was the largest ferry operation in the world by the late of 1920s. This ferry company resulted very important for the regional economy. A ferry trip was taking about 20 minutes, but now the route by the bridge take about 27 minutes. San Francisco was the American city with the most important ferry company, because they need to create link with the other communities in the bay. Although the ferry was an option, they thought in the construction of the bridge that could link both places in an efficient way. But the experts said that a bridge couldn't be built across 2,042 meters straight. Strong swirling tides and currents, the depth of the water and winds wouldn't permit the construction of the bridge. The official proposal began in 1916, when an engineering student, James Wilkins, estimated the cost of a bridge in the city, $100 million. The amount was impossible for the moment, and he asked in the bulletin if exists another proposal that can be built for less. Strauss promised that his bridge design could be built for $17 million. And a suspension bridge design then began. There was litigation about the project because the Department of the Guard and the Ferries Company wasn't agreed with the construction of a bridge. Department Guard because they feared that could be an obstacle for the ship traffic, and Ferries Company because of the business. On the other hand, for the city and for the automobile industry means great benefits. The design began, and Strauss was the chief engineer. He had to design and build the project. However, he needed a lot of help by another experts because he had little understanding or experience with cable suspension designs. Irving Morrow, residential architect, designed the shape of the bridge towers, the lighting scheme, and Art Deco elements such as a street light, rail line, and walkways. The orange color of the bridge was originally used as a sealant for the bridge, but then the locals wanted the color as an icon to the place, and enhanced the bridge's visibility in fog. Charles Alton Ellis, principal engineer, and Leon Moises produced the basic structural design. The construction began on January 5, in 1933, and was finished in April 1937. Dimensions: total length 2.7 kilometers, width 27.4 meters, height 227.4 meters, longest span 1,280.2 meters, vertical clearance 4.3 meters at toll gates, higher truck loads possible, clearance below 67.1 meters at tide. The weight of the roadway is hung from two cables that pass through the two main towers and are fixed in concrete at each end. Was the longest among suspension bridges until 1964, and also had the world's tallest suspension tower at the time of construction and retained that record until more recently. The Golden Gate Bridge means a structural challenge for its time and brings great benefits to the inhabitants of the region. At present, it remains the icon representing the city and the key element in the development of the city.